3, or chapter 3, just kidding, chapter 6, lesson 4, the final lesson in chapter 6, because there's only 4 tiny little lessons. I already talked about this, kind of introduced some of the vocab before you guys went to lunch. A dilation. We still have the terms pre-image and image. The scale factor is what we are either increasing or decreasing the picture by. And I also talked about the fact that a dilation isn't always an enlargement. Sometimes it's an enlargement. Sometimes it's a reduction is the word they use if it gets smaller. It depends on the value of the scale factor, which is K. If K is greater than 1, it will be an enlargement. But if K is between the values of 0 and 1, so if it's a decimal or a fraction less than 1, it will actually make it smaller. And all we have to do is, if they give us the scale factor, say they dilate it by a scale factor of 3, we just take each of the coordinates of all of our points times that scale factor to find the new coordinates. Okay, so down here on slide number 3, it says we use the variable K to describe the scale factor. Blank is when the image is larger than the original, so that was an enlargement. In other words, when K is greater than 1, when K is bigger than 1, all we do is multiply K by both your X and your Y coordinates. A reduction is when the image is smaller than the original, less than 1, but obviously it still has to be positive because we don't deal with negatives and dilations. And it says divide K, or divide each of your coordinates by K, but realistically, it's just K is a fraction, and we'll talk about that. So here's what we do. Let's say here's our vertices, W, X, Y, and Z. Find the coordinates of the figure after a dilation with a scale factor of 2. You guys, all you have to do is take every single number times 2. So W prime, because that's how we note it after the dilation, is going to be -4, 8, because we take -2 times 2 when we take 4 times 2. X prime is going to be, if I multiply them by 2, 2 and 8. Y prime, multiply by 2, we'll get -6 and -2. And then the last one, Z prime, will be a 6 and -2. So all you have to do, if you know the coordinates and you know the scale factor, you just multiply each coordinate by that number. That's it. All right? So take a look on slide number 4. Here's the type of question they will give you. Once again, they're going to say, hey, graph the pre-image. Graph the original one. I'm going to grab 2 different colors of pen here. I have a purple. So I'm going to start with my pre-image. I'm going to make it pink. So plot those points. -1, 1 is F. 1, 1 is G. 2, -1 is H. So F, G, H, and I is -1, -1. Now what's really cool about this particular image, you guys, is that because in this image, you notice how every single coordinate is in a different quadrant. So what's cool about this is when we multiply everything times 3, because that's the scale factor, it's going to look really cool. So first, let's write them down. So F prime multiplying by 3 is -3, 3. G prime, 1 and 1 makes 3, 3. H prime is going to be a 6, -3. And then I prime, -3, -3. So when we graph these, F is -3, 3. G is 3, 3. H is 6, 3, or sorry, negative 3. And negative 3. Negative 3 is I. What's super cool about this is, and this won't happen very often, but this one kind of blows up and it's got the other one kind of centered right in the middle of it. The reason that happens so nicely is because each point is in a different quadrant. That won't usually happen like that. If we look at the example on slide number 2 up here, you will see that, you know, you started with a small triangle and then it got bigger up here. And so notice the smaller one isn't always going to be perfectly centered inside the bigger one. So this one just happens to be that way because they're all in a different quadrant. It's kind of cool. Questions on that so far? All right, let's flip her over. And we're going to talk about what this means in terms of word problems. What does a scale factor mean? Okay, well, a scale factor is what we multiplied them by. So in this question, it says through a microscope, the image of a grain of sand with a 0.25 millimeter diameter appears, obviously bigger, it appears to have an 11.25 millimeters diameter. What is the scale factor? So here's a really, really important thing to write down. In order to find K, what you're going to do is you're going to take the new divided by original. So the new measurement over the original measurement. Notice I put the little apostrophe there because that's how we always denote the new one, according as opposed to the pre-image. Now the new one in this case is 11.25 millimeters, and the original was 0.25 millimeters. And then we can reduce that or divide it to find the original, or to find what it was we multiplied by. In this case, it's going to be a whole number, or yeah, a whole number. It's going to be 45, right? So K is 45. It became 45 times bigger. Now, I wish they were all that straightforward, but they won't be. This, however, is pretty important to find our scale factor. Okay? Sliding over to 6, we got a little bit different kind of word problem. It says Lucas wants to enlarge a 3 by 5 inch photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? Now, what's interesting is they gave us 4 measurements, didn't they? They gave us 4 measurements. If I just make a sketch, the original measurement was 3 by 5, right? And he's going to enlarge it. So this is original, and this is the new. So it's going to be bigger, and it's going to be 7.5 or 7.5 by 12.5. What's cool about this is it doesn't matter which set of numbers I use. I could put 12.5 over 5, or I could put 7.5 over 3. It does not matter. So whether you use 12.5 over 5 or 7.5 over 3, you will get the same answer. And if you wanted to do both of them, double check, you could do that. Anybody got your calculator out? You can tell me what you get when you take 12.5 divided by 5? Although I think I know. I think you get 2.5. And is that the same over here? 2.5. So your scale factor is 2.5. But they give you a question like that really to kind of confuse you because they give you 2 separate possibilities that you could use. Okay, let's try the one right below that. Darlin wants to build a regular size pool table. A regular size pool table. That is 9 feet in length. The plans he ordered are 18 by 36 inches. Couple things here. What's the scale factor of the dilation he must use to build the regulation pool table? Couple things here. One, we only get one measurement for the actual table, right? And two, that's in feet and this one's in inches. All right? Interesting. What's that? We could convert feet to inches. Yeah, we could. But which one does 9 correspond to? It says 9 feet in length, and then it gives me 18 by 36. When they refer to length, if I'm talking about a rectangle, which one do they usually refer to? The longer of the two, right? In other words, 9 feet is going to correspond to 36 inches. So new divided by original, new is 9 feet, and I'm going to leave my units on there because I don't need them just yet, and 36 is the original model size, 36 inches. Excuse me. Now when we are giving a scale factor, we must be in the same unit. So whether you change feet, the 9 feet to inches, or the 36 inches to feet, because how many of you know 36 inches goes very nicely into feet, right? How many feet is that? 3. Whether you change it both to feet, what's 9 divided by 3? 3. Now, what if I would have said, oh, I want to make them all inches? What if I would have done that? What do I got to do to the 9 feet? Ooh, times by 12. What's 9 times 12? Somebody help me out. I think it's 108. Hey, what's 108 divided by 36? It's 3. So it doesn't matter which unit you put it in as long as the new and the original are in the same unit. So if you wanted to make them both feet, you get 3. If you wanted to make them both inches, you still get 3. But new divided by original. One more example, right? Last slide. Mrs. Bowen's homeroom is creating a web page for their school's intranet site. I'm not sure why it's intranet, but whatever. They need to reduce a scanned photograph so that it is 720 pixels by 320 pixels. If the scanned photograph is 1080 pixels by 480 pixels, what's the scale factor? Remember, it's new over original. And they gave us 2 sets of numbers. You don't have to use both of them. Which set do you want to use? Do you know what I would use? The smaller one. Less math that way, right? But which one is my new and which one is my original? It says they need to reduce it to this size. So this is the new because it's getting smaller, and this is the original. So it's going to, and they're both in pixels, so we don't have to worry about changing our units. So we got 320 over 480. Now, hopefully you can identify the fact that that's going to be less than 1. Now, if it's less than 1, you guys, I prefer it as a fraction. So let's reduce this. Real simple. I can reduce it to 32 over 48. What goes into both 32 and 48? 8 does, right? How many times? 4 and 6, which is also reduced to 2/3. And there's your scale factor. So you will have a worksheet to do, and I'm not done, but I'm going to stop my recording here. But you have a worksheet. It'll be blue. If you have any questions, you need to come and see me.